Alright, Eagles. Yeah, that's a good intro. Alright, Eagles. We are gonna pick up with dimensional analysis again, this time looking at shifting from imperial units to metric, because honestly, metric units are so much better than imperial units. I mean, look at this thing. An inch is divided into sixteenths, which doesn't make sense to begin with. So 1 inch is divided into sixteenths. 1 foot is 12 inches. So we had sixteenths, now we have inches, 12 of them. 1 yard is 3 feet. Alright, going back down. And then a mile is 2,580 feet. Who comes up with this junk? It's ridiculous. 16ths, 12, 3, 2,580. It's garbage. Then you have the metric system, where 10 millimeters will get you 1 centimeter. 100 centimeters will net you a nice meter. And 1,000 meters will get you a whole kilometer. Now, there are other units in between centimeters and meters and meters and kilometers, but it's all about changing in powers of 10, which is the absolute beauty of the metric system. It's just so beautiful. Now, it's been like 4 or 5 months since I looked this up. If I recall correctly, the entire reason the United States is still in the imperial system is because when the metric system was becoming common, England switched to the metric system, and the United States did not want to be like England because they're still trying to, identify themselves outside of being a colony. And basically, it's because they were petty, and I feel that. But it's so frustrating. Let's use an example that you guys are gonna feel comfortable with. If PA, the state you live in, let me scroll, there we go. Is 300 miles from east to west. How many kilometers is it? Now, I'm going to let you all know, I'm going to separate that the conversion factor for miles to kilometers is 1.61 kilometers per 1 mile. So why don't you all go ahead and try to puzzle this one out. And while you do that, I'm just gonna, hang out in this corner, draw things. Yeah. Alright, hey, listen. The way I would set this up is take our starting value, which is 300 miles, but then the starting portion of our dam, or our dimensional analysis machine. Then I'm going to input my conversion factor. Remember, the units you want to get rid of need to be opposite each other. So since I have miles, on top in the starting section, I need to have miles on the bottom in the conversion section. So I'll set up my conversion factor with 1.61 kilometers on top and 1 mile on the bottom. Do some math. You multiply across, divide down. We don't have to worry about dividing because it's just dividing by 1. That's easy peasy. Y'all should be able to do that in your head. But multiplying across, you will get 483 kilometers is equal to 300 miles. Alright, so we did all that. Let's go ahead and do another practice, because I know how much y'all love that. Let's use a different color. Let's use... You know what? We'll use white to write the question. In that case, switch to a different layer. Here we go. Alright, so an anaconda can grow to about 30 feet long. I know this because I did a project on it in the 4th grade. And let's convert that to meters so that, I don't know, you're a scientist studying anacondas. You measure it in feet. Well, your French colleague wants to know what it is in meters, so you have to convert this to meters. The conversion factor between feet and meters is 1 meter is equal to 3.28 feet. Alright, now while y'all work on that, I'm just gonna, I don't know, this is a snake. You can tell because it doesn't have any arms or legs, and it has scales. And a tongue. That's the snake. Okay, time is up. Let's go ahead and set up this problem. So we'll start with our starting value, 30 feet. Oh yeah, that looks cool. I'm here for it. In our DAM, dimensional analysis machine, since we have feet to start with, we'll put 3.28 feet from our conversion factor on the bottom, 1 meter on top. You multiply across and divide down. And what you get, 30 times 1, let me check my math, is 30. And then divided by 3.28 is going to give us 9.15 meters. So I didn't do this in the last one, but your units will cancel out, and this can be useful if you have a lot of conversions going on in the problem. I just saw Frozen 2, and now Into the Unknown is stuck in my head. I'm sure some of you will understand how that feels. Now let's do another practice. A road is 5,423 meters long. How many kilometers is this? Now I've already given you the conversion factor earlier in the video, so I'm going to go ahead and leave you guys to that one while I doodle over here. Doodle-doodle. 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 All right. So you start with 5,423 meters as the start. I forgot to make that all in a different color. Let's use blue this time. 5,423 meters is our start. The conversion is 1,000. Meters for 1 kilometer. Multiply across and divide down. If they're on opposite sides, the units cancel. So then we will have 5,423 divided by 1,000. Here's a cool thing. Whenever you're dividing by 10 or 100 or 1,000 or 10,000 or 100,000, the way it changes is it takes the decimal point, and if you're dividing, it'll move to the left. If it's multiplying, to the right, it'll add zeros. So there are 3 zeros here. We're going to move this decimal 3 times. So our answer, we can do this without even using a calculator, is 5.423 kilometers. Alright, last one. Because last time YouTube yelled at me for my video being too long. A fish egg is 0.67 centimeters across. Well, 0.67 isn't a very nice number to work with, so let's convert that to millimeters. The conversion factor is already in the beginning, so y'all can go ahead and look at that. Alright, let's use this color now. So our starting value, 0.67 centimeters. Plug that into the DAEM dimensional analysis machine. Conversion factor is 10 millimeters per 1 centimeter. Now remember, you multiply across the top, divide across the bottom. And remember, opposite units, top versus bottom, they will cancel out, which is what we want to happen. We don't want centimeters and square centimeters. It's just going to get annoying at the end if that happens. And that's going to give you, because we multiplied by 10, this decimal moves 1 point to the right and gives us 6.7 millimeters. Alright, so that is how you do dimensional analysis. I hope that helps. I encourage you to keep practicing, and I hope to see you in the classroom again very soon. Stay safe and stay healthy.